In this video, we're going to learn how to solve for missing side lengths in a right triangle. We're going to be able to use a calculator to do this. First of all, I want to talk a little bit about the calculator. In order for us to do this on the screen, I'll try to zoom in on this, need to be able to see either a DEG, which you do here, or on this calculator, see a D, on this calculator, DEG, and maybe you figured out by now the D and the DEG stand for degrees. Okay, there are other ways of measuring angles other than in degrees, but we have to make sure our calculator knows that we're going to be using degrees. Now we can see these keys that have the abbreviations for sine, cosine, tangent. Those are pretty familiar and the same on all these calculators. However, how we enter things is going to be a little bit different depending upon the calculator. If we see all of our operations as we enter them, here's an example. If I took 3 times 5 minus 4 times 6, see how everything is showing up. That's going to be different than if we just see one number at a time. 3 times 5 minus 4 times 6. Oops, I missed the times there. But I don't see all the operations. So we'll address those as those come up. Now, in this particular triangle, I know one acute angle is 18 degrees, and I know the hypotenuse is 12 units. To help us remember our little memory device, SOHCAHTOA. And so if I'm trying to find the x, I have to see how it relates to that 18-degree angle. Well, notice the x is the opposite leg from that 18-degree angle. The 12 is the hypotenuse, so that would be the sine. Sine is opposite leg divided by hypotenuse. So when I write an equation that describes that relationship, I'd have the sine of 18 degrees is equal to the opposite leg, which in this case has a length of x, divided by the length of the hypotenuse, which is 12. Before I ever touch my calculator, I solve that equation for x. Here we have x divided by 12. So to reverse division, I multiply. So if I multiply both sides by 12, x is going to equal 12 times the sine of 18 degrees. So on this calculator where I see all of my operations, it is on degrees. I'm going to enter 12 times the sine of 18 degrees and close off the parentheses. My calculator knows it's degrees because that's the mode it's in. And so now when I hit equals or enter, we see that x is about 3 7/10 if we are rounding to the nearest tenth. Now it's not exactly 3 7/10, so I use that wavy equal sign to mean that x is approximately 3 7/10. Now if I were using a different kind of calculator, this one does not display all the operations. I have to do things a little bit differently. here I would take 12 times, but now I have to do the 18, then the sign, and now equals. And we see we get that same value. Let's repeat that one. 12 times 18, and then the sign. Now notice that's only the sine of 18 degrees. We still have to tell the calculator to do the multiplication, so then I hit equals or enter. Now, let's suppose we want to find y. Well, related to this 18-degree angle, y would be the adjacent leg. Okay, you can say, well, why isn't 12 adjacent leg? Well, remember, 12 is the hypotenuse. So the adjacent or next to leg, 12 is still the hypotenuse. Now, even though we've found an approximation for x, I only want to use the exact values I'm given to write my equation. I don't ever want to use a rounded value to do another calculation if I can help it. And I can help it here. So, adjacent leg and hypotenuse, that's the cosine. Cosine is adjacent leg divided by hypotenuse. So our equation would be cosine of 18 degrees equals, the adjacent leg is y, the hypotenuse is 12. So haven't touched my calculator yet. Solve for y. So we need to multiply both sides of the equation by 12. So y would equal 12 times the cosine of 18 degrees. Now, get my calculator out. This is one where I see all the operations. So I have 12 times cosine 18. Get that out of the glare if I can a little bit. Hit enter, and that value is about 11 4/10. I would have used one of these other calculators. Okay, here's the one where I don't see all the operations. So 12 times 18 cosine. So I found the cosine of 18 degrees, but it hasn't multiplied yet. Now hit equals. So about 11 4/10, just like the other one. I actually have another example. Let's suppose that we had this right triangle and we have this 72-degree angle. Now notice that M is the length of the leg opposite the 72-degree angle, and 7 is the length of the leg adjacent to that 72-degree angle. I don't know the hypotenuse. So if I'm thinking of SOHCAHTOA, opposite leg, adjacent leg, oh, this is tangent. So the tangent of 72 degrees is equal to the opposite leg, M, divided by the adjacent leg, 7. To solve this equation, I'm going to multiply both sides by 7. So M is equal to 7 times the tangent of 72 degrees. Once I have my equation solved for my variable, now is when I'd use my calculator. So this calculator, I don't see the operations. So 7 times 72 tangent. Okay, remember that's just the tangent. Hit equals to do the multiplication. So M is about 21 5/10. Now, some of you might be wondering, well, suppose that we would have found this acute angle and then worked with it. And that works. Remember, the two acute angles have to have a sum of 90 degrees. 90 minus 70 is 20. 20 minus 2 is 18. If I would have used this 18-degree angle, this would have been the opposite leg. This would have been the adjacent leg. That's still tangent, but our equation would look a little bit different. Here, our tangent would have been opposite leg divided by adjacent leg. The variable would have been in the denominator. Well, remember, this is a ratio, this is a ratio. As long as the cross products are equal, the proportion is true. This would be the same as tangent of 18 degrees divided by 1. So if I have 1 times 7 and tangent of 18 degrees times m for our cross products, it doesn't matter where they are. So notice I could switch the tangent of 18 degrees with the m, and I still have that same cross product, right? 1 times 7, tangent of 18 degrees times m. So if ever our denominator has the variable, just switch it with the other numerator. So now in this case, if I take 7 divided by, let's see if you can get that in there, the tangent of 18 degrees, see, 21.5, same thing. Or on one of our other calculators that we didn't see the operations, 7 divided by 18 tangent, don't forget to hit equals, there's 21.5. So, if ever your equation involving your trigonometric ratio of sine, cosine, or tangent has the variable in the denominator, just switch that denominator with what's on the other side of the equation, because you're just switching a diagonal product factor in a proportion.